I've got a handout I'm giving you guys from. Okay? Alright, so just so you understand where to use these, right? These right here that we've been doing, alright, just kind of keep in mind, right? These are all for right triangles. Okay, so the only time you can use the basic ratios of sine, cosine, tangent in the manner that we've been doing it is strictly for right triangles. Which for you guys, that's how most of the triangles get dealt with. Okay, we always try and break them back down to right triangles because the basic proportion is a lot easier to work with than some of the things we're doing today. Okay, so everything after this, just kind of keep in mind, everything after this does not have to be a right triangle. This is going to be for any other triangle that exists. Okay, so first thing talking about is this, law of cosine. Okay, the law of cosines is essentially the three formulas at the bottom. They're exactly the same, they're just interchanged with the letters. Now this triangle that's drawn up there, with the capital letters A, B, and C being the angles, and the lowercase a, b, and c being the sides that are opposite the angles, like little a is opposite capital A, little b opposite big B, so on. That's like the basic triangle that is used whenever you present the law of cosines and then the law of sines here in a second. Alright, so that the triangle is just serving as kind of like a formula for you. Like, so what you got to understand is this whole thing is like a formula altogether. Okay, now, the time you're going to use this would be like if I gave you a triangle and I wanted you to find maybe a side length or maybe an angle measure, and I gave you one of these situations right here. So you had two side lengths and an included angle, which two side lengths and an included angle would be like this 10, 12, and like 43. That would be two sides. That would be the included angle. Or if you had three side lengths and I said solve the triangle, then you would go back to using this. So this right here tells you what situations these formulas are going to come up. Alright, and right down here, this is telling you where to plug in the numbers. And it's probably going to be easy, like if you were to go on each triangle, and before you even started the problem, you labeled the sides like A, B, C, A, B, C, like that, you can just take what you have labeled and plug them in. Like you would do a Pythagorean theorem, like you would do a quadratic formula, you can do any kind of formula. Okay, and when you do that, you're always going to have one unknown. Be it an angle measure here, a side length somewhere in here, doesn't matter. Okay? And in reality, it's the what you want to pick, especially if you're doing something where you're just finding a side length, which these are written out to solve for side lengths. What you want to do is you want to make sure you pick the one where this side right here is the side you're trying to find. So like the way I have this triangle labeled, if I said what's the value of this side, like if I was asking what's that side, and I labeled it A, B, and C in the manner I did, I would look at it and see like C is the side that I'm trying to find, so I would use that one. Alright, they're all the exact same. The only thing that's changing is where the A's, B's, and C's are. Alright, so guys, just kind of get these down. This is kind of like a formula thing. Okay, and I'm going to do one or two examples, and then I'm going to have you guys try a couple on your own. Alright, and then we'll do the other law. We're doing both of them. We'll do law of sines and law of cosines. Okay, I'm doing the one that is more difficult looking first. The law of sines is a little bit easier to deal with. Most people like that a little bit better than this. Okay, I'll give you another second if you're writing this down, and then we'll go on to the problem. do the first one I do. I might do another one after. Okay, so so with this problem, it would be simply solve for x, right? Or find the value of x, whatever. And what you would have to do, right, in terms of the test, especially in terms of the test, on the test, I might give you like one problem that fits what we're doing today. Maybe like one regular, one that's like an extra credit kind of problem. Because most of the focus of the entire chapter has been right triangles. So just kind of keep that in mind when we're doing this. All right, like there will be a test question on it, but most of the test is going to be focusing on the right triangle. Okay, so what you would have to do is you have to look at it first and go, well, it's not a right triangle, or at least I don't know it's a right triangle because there's no right angles in it. So I mean, since it's not a right triangle, I'm going to have to use one of the two laws today. And since we've only done one of them, we're sticking with the law of cosines right now. Which even once we do both of them, you're going to have to be able to look at this and tell which law to use. All right, now we know it's cosines because I got two sides and I got the angle between the two sides. So what I'd say, and what I'm just suggesting for you guys right now, is to go up there and label the sides and angles in such a manner that it fits the formula kind of thing. So if I label these angles A, B, and C the way I did, this side right here will become little a because it's opposite angle A. B, and C.
So no matter like if it was like a different way.
Going at that, like with the labeling you mean?
No, like I understand how to like take a little and big like and not like the constant, but it doesn't matter if it was like between the other two.
You mean like what the numbers are?
Yeah, do you think that has to be exactly like A down here, B down here, C here? Okay.
No, that can change. All right, so if I was going through and trying to pick which one of the three, since I had all three written out, right? I had all three formulas written out, you know, they're exactly the same. If I was picking it and I was looking back at my notes, I would go, okay, the side that I have labeled A here is what I'm trying to find. So I would go and I go, okay, the law of cosine says if I want to find A, I have A squared equals. This needs to be the one I pick as the one that has this by itself, because that's the side I'm trying to find. All right, and then the rest of it I just write out exactly like it was in the notes. C squared plus C squared minus 2bc times the cosine of A. Understand, guys, this whole thing right here, this is all multiplied together. You find the cosine of that angle, you multiply it by that part. Okay? So understand, this is all multiplied all together in one shot right here. 2 times b times c times the cosine of A. Okay, so if I just use what I've already labeled up there and plug them right in, I'm going to have x squared there. The b was 23, so that's 23 squared. 27 squared minus 2. B is 23. C is 27. And the angle that I have labeled as A is 6. Okay, so really if you can get to that point, guys, it's just a matter of making sure you do your order of operations correctly. Okay? So someone's got a calculator out. Big numbers. 529. 529 plus. What is this part? 2 times 23 times 27. And then what's the cosine of 36? 809. Okay. Now the reason I separated that is just so you understand. These get multiplied together. Remember, that's the number you get from your calculator or from the chart. And then you go ahead and multiply these together after the fact. All right, so I'm going to have 529 plus 729 minus whatever that is. 1,004. All right. So what is this now all together? And finally, the last step would be take the square root. Guys, don't take the square root, they move this all down to one number. The square root. Alright. So all that stuff right there would be for that one value, okay? And again, this is simply for a non-right triangle. If this was a right triangle, it would have been easy. If this was a right triangle, I'd put down my Pythagorean theorem. Okay? So this is for the things that aren't right triangles. Alright? Okay, let me do one with an angle measure. Usually that gets people. This one usually doesn't confuse as many people. It looks like a lot more work than it actually is because you got a whole bunch of numbers you multiply together, which means that there is room for mistakes in there. Okay? So can I go faster? Yeah. Alright, so take up a little smaller. Give myself room. Give me a number here. 30. 17 what? 25. Give me a number that would make sense.
35.
What?
35.
Yeah, sure. That'll work. Okay. And we'll find, like, let's say, this angle right here. Okay, so again, this is going to be a find the value of x. And again, the way you need to still think about it is it's not necessarily a right triangle to have the angles marked as the right angle. Okay, it probably isn't a right triangle. Alright, so I'm going to go up there, I'm going to label all my sides the same way and all my angles the same way I did last time. So this time I called that A, B, and C. Doesn't matter where you put those. The only thing that matters is wherever you put the A, make sure the lowercase a is opposite A. Lowercase c and lowercase b. Alright, so I'm still going to pick this the same way I did the last one. Which as I'm trying to, my x, where I put it, is with angle A. So I need to pick the law of cosines formula out that had cosine of A in it, which was basically the one I just used. So, CBC, cosine of A. The only thing is when I plug my numbers in here, this cosine of A is going to be the thing that doesn't change, right? Because I've got all the side lengths. So when I plug it in, I'm going to have a number there. I'm going to have a number there. There. 25 and 2. Okay? Now look, since I'm finding an angle measure, I'm still going to use the -1 thing. But remember, I can't do that until I have cosine of A completely by itself. So this goes back to just the way you solve a normal equation. You get the variable, what you're trying to find by itself, which is cosine A, and all the numbers on the other side. Okay? All right, which means if I were to start working through this, right? I think I'm making enough numbers. What's 35 squared? 1, 2, 3, 5. What's 25 squared? 17. All right, and then here's what you need to do. This all needs to be multiplied together, and the cosine A will stay at the end of it. So 50 times 17 is 50. All right, now here's the biggest mistake with this, is people see minus 850, and what happens is when I start moving things, they think they're going to add the 850 to the other side. But what actually happens, you got to remember, 850 and the cosine A, this whole thing is multiplied together. So the only thing I can really do in terms of adding and subtracting is I can subtract that to the other side, and that to the other side. Okay? Because that would be how I move it. So if I did 1225 minus 625 and minus 289, that would move those both to the other side. Okay? So what is 1225 minus both of those? So you're down to a problem like that. Okay? Alright, and then the last thing you would do before you do this part right here is now you got to divide by that negative 850. Okay? So do 11 divided by negative 850. What's this as a decimal? 265. And then that's what you're going to be doing the inverse cosine of. You need a calculator for this stuff, guys. A lot of these aren't going to be on the chart. Okay? And once you go beyond non-right triangles, you can have negative values for these right triangles always be positive. So if you do cosine -1 of that negative 3659, you should get, sorry for that, it's 111.5. So that would be what the answer is there. All right, here's what I want you guys to do. Is a little bit more straightforward because proportion. Now, the law of sines. So again, this is for non-right triangles. This is a right triangle, I would just go back to regular sine, cosine. But if I don't know it's a right triangle, and I just have a triangle there, and I'm asking you to find either a side length or an angle measure, and I have one of these two situations come up. The two side lengths and a non-included angle. So that non-included means it's not the angle right between the two sides. So non-included angle would be like if I gave you this side, and this angle, okay? That would be non-included angle. Or if you've got two angle measures and then just one random side length. And for most of these cases, you know, I would ask you to find another side length or another angle measure, just like with the past problem. But the law of sines basically becomes one big proportion. Okay, and just like with the 30, 60, 90 stuff, especially right triangles, when you're doing these, you're just going to pick two of the proportions to work with. Right? One of them has to have a number at top and bottom. The other one has to have a number on one part of it and the variable on the other that you're trying to find. And since it's a proportion, you just cross multiply. So a lot of people like dealing with this one better because you don't have to square things, you don't have to add them, you don't have to subtract them. There's less places for you to make a arithmetic mistake here because you're simply going to be cross multiplying. Okay, but you have to kind of discern between the situations here. Like law of sines, you have to have one of these two come up. The two that I defined for law of cosines, you have to have them exist to do law of cosines. Okay, like the last two problems, the last problem that was up there, the one I did, and then the one I wanted you to do the classwork, you couldn't use this right here for that problem. Okay, it wouldn't have worked out. You would have had too many unknowns, you wouldn't have been able to cross them. Okay? Alright, but again, you're just making these decimals like sine of an angle, you plug it in the calculator, it goes to the chart. At least you, for what you could on a chart. If I was over 100 degrees, obviously you would definitely need, or over 90 degrees, then you would need a calculator for that. Okay, so if we're dealing with non-right triangles, you know, you're probably going to have an angle that's greater than 90, or they could all be less than 90. Okay. Can you go past this yet?
No.
Right past. Just like the last one, guys, I'm going to do one problem, and I want you guys to try one. Okay? On your own. Yeah, and then we're done after that. Maybe like 3 above this stuff. 2 or 3. But then I have other stuff.
Okay.
In 5 hours. 5 hours, you know, really? Maybe like 5 out. Well, I guess when we get more used to it. Alright. So this one right here, guys, this would be the situation where I've got two angles, one side length given to me. Okay, so since I have two angles and one side length, that means I have to use the law of sines in order to find the other side. Okay, I can't do regular sine, cosine, tangent because it's not a right triangle. And I don't have enough information to fit it into the law of cosine. But what I would say do is still label the triangle with angles A, B, and C, and go like little c, little b, and little a, just to kind of remind yourself that, because that's how the formula is just set up. It's easiest to relabel things that way so it matches up. All right. So with this one here, I'm trying to find the side that I've labeled C. That means one part of my proportion is going to go sine of angle C over C. So I'm doing the one that goes sine of C over C. All right, and then the other one is going to be, I don't have side A, so I don't care about that one, but I do have side B, and I have angle B. So I'm going to do sine B over B. Okay, so it's just like a mix and match kind of thing. So my proportion is going to look that way. So this is just a cross multiplying. Okay, what I would probably suggest you do is make both those signs decimals, so you don't confuse yourself in terms of what you're multiplying together. So like, what's the sine of 110?
939.
What?
No, 9397.
Oh, 939.97. So over x, what's the sine of 40? 8. All right, and then once you're there, guys, it's just a matter of cross multiplying, right? So x times that goes together. And then 12 times 0.9397. I can actually get a number for that, which is what, 11.1. 3. And then the last step, since this is x times that decimal, remember you're going to divide by that decimal to get to the other side. So 11.3 divided by 0.64 is, what is it, 17? 5? 5 or 6? 6. There we go. Alright, it's a little bit less work than cosine, or at least it looks like less work, you know, stepwise, because you're just doing a quick multiplication and maybe a division. Okay? Alright. And even if you were doing an angle measure, like if, can I go past it? Alright, even if I gave you, I'm trying to, give me a number here.
12. 14.
Wait, 24.
24.
I heard like
16.
4.
23.
97.
23.
97? That's not gonna work. I got
43. 23.
You want 97?
56.
Oh.
Move.
Okay, so if I was doing this one again, like I've got two sides, not included angle, I want you to find me another angle. And again, the two problems can be put together, like in one. I could also go, you know, after you find that, find me this side too, but we're just going to do the angle now. Alright, so I would say, look, I got two sides, and they're not included angle, that means I'm doing law of sines. I would probably still label all my things A, B, and C. Okay. I don't have anything on the on either A, so that means my setup is going to go like sine of C over C equals sine of B over B. Okay, so if I fill in what I have, I've got angle C on my triangle listed as 97 degrees. Side C I have as 20. The sine of B is what I'm trying to find. And then side B I have as 12. Okay? You can make this a decimal. Sine of 97 divided by 20 will give you a number. So what is the sine of 97 divided by 20, like all in one shot. What is that? One what? I know that goes with 0.0497. Yeah. Right? Now here's the thing, if I want to get sine of x by itself, what do I need to do here? Multiply by 12. There's no really need to cross multiply, right? Because that's going to be over 1 anyway. So if I just multiply that by 12, that gives me what? What's 0.0497 times 12? 588. 596. How are you so far off? 596? No. This number right here is sine 97 divided by 20. It's already done.
Oh.
So once you do that division, I'm saying is over 1. And then guys, last step would be just like any other problem. I've got sine of x equals a number. Use that thing to get rid of it. Get x by itself. So you sine, inverse sine 5964, which is 36.6. Okay? Not really. That's not what you do.
Oh, no.
This one is.
All of these are so. I mean, they're kind of.
This one,
simple, but
this one's more like the stuff you do. The first one on, okay?